I am a creator. Blending art and technology. To immerse our senses. I am a healer, helping us take the next step and see what's possible. I am a pioneer, finding life-saving answers. And pushing the edge to the outer limits. I am a guardian, defending our oceans.
Roger that. Fly-by inbound.
And the magnificent creatures that call them home. I am a protector, helping the earth breathe easier. And watching over it for generations to come. I am a storyteller, giving emotion to words and bringing them to life. I am even the composer of the music. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Taiwan has always been a very special place for NVIDIA. From system builders and solution providers to universities and the government, all have partnered with us. On behalf of Jensen and NVIDIA, thank you to all of our many friends in Taiwan who have worked alongside us to enable these amazing AI breakthroughs. Together, we have laid the foundation for a new computing model based on AI, software that writes software. This foundation includes GPUs deployed in the cloud and in data centers, AI software and SDKs tailored to the world's largest industries, and an ecosystem of startups and developers. Now it's time to build the house on top of this foundation. It is time to democratize AI by bringing its transformative power to every company and its customers. There are three fundamental shifts that will bring AI to every company. The first shift is that every application used by any company will be infused with AI. AI is essentially a two-step process. First, a rich set of existing data and known outcomes from that data are used to train a model. Then, the model is applied to fresh data to make fresh judgments. The model is effectively a piece of software that can be embedded into any application. As the application runs, it queries the model to make judgments, giving it intelligence. As new data becomes available, the model is retrained and improved, automatically making the application better without human developers having to create a new version. A great example of this infusion of AI is in Microsoft Office, the world's most popular productivity application. Microsoft is adding smart experiences such as smart grammar correction, Q&A, and text prediction to Office. With NVIDIA GPUs, Microsoft was able to improve responsiveness to less than 1/5 of a second, enabling real-time grammar correction, and at 1/3 the cost of the same work on CPUs. Going forward, every application will have to be built in this way or be left behind. Now, this is not the first time we've seen this kind of shift. For example, consider the introduction of the graphical user interface, the GUI, Once the transformative value of GUI became evident, every command line application had to adopt GUI or be left behind. In the same way, every application will need to be infused with AI. And all of these applications will need the most performant, power-efficient, and cost-effective systems to run on, regardless of form factor or location, from edge to cloud. Every system will need a GPU. The second shift is that every data center used by any company will be infused with AI. Computing is increasingly being driven by large amounts of data. Neither the data nor the computation done on it can fit on one server. Therefore, the flow of data through the network becomes crucial to both the capability and the security of the data center. A new kind of hardware is needed that sits on the data path and intelligently optimizes, inspects, and protects the data, and protects the applications from one another. This new hardware is the Data Processing Unit, or DPU. Every server will need a DPU. The third shift is that the life cycle of every product produced by any company will be optimized by AI. Consider the very common and old-fashioned example of soap. Yes, soap. Going forward, a soap company will design and tailor its soap product portfolio by analyzing rich data on the usage and experience of the customer base. The soap manufacturing process will be automated and optimized with AI. Customers who use soap, pretty much the entire population of the world, will be engaged socially and sold to online. Smart soap dispensers will track usage and automatically order refills. And all the data from the customer experience will be fed back to guide the design and supply chain of the soap. This soap company and every other company will need a new form of IT and IT infrastructure to operate the AI-optimized lifecycle of its product. These are fundamental shifts that will require massive amounts of accelerated computing. Now let's talk about how you can build on the technology foundation of NVIDIA to make this a reality. How you can democratize AI. We start with the hardware. NVIDIA DGX is the instrument of AI. Since its launch in 2016, DGX has been used by companies across industries at the forefront of AI. The reason for this is that DGX was designed from the ground up as the optimal system for AI. Every component and every interconnect was designed or chosen with great care. And today, DGX incorporates learnings from hundreds of millions of hours of usage on thousands of systems across the planet. The pinnacle of AI capability is the DGX SuperPod, where multiple DGXs are clustered together and tuned for AI based on all of NVIDIA's learnings. So the first step to democratization is to make this best-of-breed machine more accessible and more obtainable. To make it more accessible, we are providing a software stack called Base Command Platform. Using Kubernetes, this software allows administrators to share this powerful supercomputer across an organization of data scientists and a mix of workloads. It provides users with a simple interface for AI, and it allows organizations to understand and optimize their usage of this valuable equipment. We have been using Base Command within NVIDIA for many years, sharing superpods across thousands of data scientists who have run over 1 million jobs. To make it more obtainable, we are introducing a subscription model for SuperPod. Customers can now experience the capability of a SuperPod or a smaller part of a SuperPod for months at a time. This is a hosted offering in which NVIDIA will manage the infrastructure, reducing the operational burden on customers. The offering includes powerful all-flash storage and integrated data management from NetApp, the pioneer of enterprise NAS storage. NetApp is synonymous with enterprise-grade storage, with over 38,000 customers today, on-premises and in the cloud. The subscription model is in early access now. For example, Adobe is already using the infrastructure to train StyleGAN, a powerful image generation AI. The model will open up for paid access this summer. With this offering, we expect that many more customers will be able to experience the unique capability of a superpod without the upfront investment. From there, they can graduate to more permanent infrastructure at scale, either their own superpod or in the public cloud. Speaking of the cloud, for some time now we have worked with our cloud partners to offer powerful GPU instances in the cloud, leveraging the internal components of DGX. We are proud to announce today that Amazon and Google are working with us to enable Base Command Platform for clusters formed from these cloud instances. This work offers the promise of a true hybrid AI experience for customers. Write once, run anywhere. But even as we democratize access to DGX, the larger objective is to decompose DGX into its smallest AI-optimized parts, so that system manufacturers can compose those parts into different form factors for different scenarios, while adding unique value-add capabilities for their customers. First, we productize the GPU board that combines multiple GPUs into a tightly interconnected computing fabric. This is HGX. Then, we offered the core GPU from the board as a standalone PCIe card. This is the A100. Now, we have further broken down the A100 into smaller form factor GPUs, such as the A30, that draw less power and are lower cost, while still providing powerful acceleration. And finally, we have productized the same BlueField 2 DPU that is inside DGX SuperPod, now usable in any server. With this, we have now enabled a complete ecosystem of form factors, from supercomputers to pizza box servers, workstations, and edge devices. These form factors can be used in a variety of scenarios, from compute to graphics to virtual desktops to data center infrastructure, all made better by AI. HGX boards are the engine of supercomputing. A100 and A30 are optimized for compute. A40 and A10 are best for a mix of compute and graphics. And A16 combines multiple small GPUs into a great form factor for VDI. In order to help system manufacturers create AI-optimized designs, and to ensure that the systems can be relied on by customers, we created NVIDIA Certified, a program for servers that incorporate GPU acceleration. NVIDIA Certified provides blueprints for system design, as well as test suites so that system manufacturers can validate their designs. Today, we are announcing the expansion of NVIDIA Certified to systems with NVIDIA BlueField DPUs. Going forward, the DPU will be an essential component of every server, in the data center and at the edge. This is because, as shown in the diagram, the DPU offloads, accelerates, and secures functions that must otherwise be performed by the host CPU. Last year, we announced BlueField 2, our state-of-the-art DPU. NVIDIA is working closely with VMware to use BlueField 2 as the host for their ESXi hypervisor as part of Project Monterey. This year, we released the first version of Docker, the SDK of BlueField. We expect that Docker will do for the DPU what CUDA has done for the GPU, enabling millions of developers with a long-lasting, consistent SDK that they can use from one generation of BlueField to the next. And we are especially pleased to announce that the world's system manufacturers are joining us in the DPU journey by producing state-of-the-art mainstream servers accelerated by NVIDIA BlueField 2. 3 of these companies are right here in Taiwan: ASUS, Gigabyte, and Quanta. BlueField 2 is especially well-suited to inspecting the network for security breaches. The typical approach is to run an agent on the host CPU. This approach consumes host CPU cycles and handles only a narrow window of the network traffic. BlueField 2 allows full inspection with no host CPU overhead. NVIDIA has created a software platform called Morpheus that uses the BlueField 2 and AI to automatically detect and address security breaches. Today, we are announcing that Red Hat is working with NVIDIA to provide Morpheus developer kits for both OpenShift and Red Hat Enterprise Linux, or RHEL for short. RHEL is the most commonly used version of commercial Linux in enterprise data centers today. Cybersecurity companies will now be able to use Morpheus on RHEL and OpenShift to bring advanced security to every enterprise data center. But this journey is just beginning. We are already working on BlueField 3, 22 billion transistors, the first 400 gigabits per second networking chip, 16 ARM CPU cores to run the entire virtualization software stack. BlueField 3 takes security to a whole new level, fully offloading and accelerating IPsec, TLS cryptography, secret key management, and regular expression processing. Whereas BlueField 2 offloaded an equivalent of 30 CPU cores, it would take 300 CPU cores to secure, offload, and accelerate the networking traffic at 400 Gbps. This is a 10x leap in performance. BlueField 3, the next generation, but the same Docker SDK. Today, we are also announcing the expansion of NVIDIA Certified to accelerated systems with ARM-based host CPUs. As the GPU and DPU accelerators take on more of the compute workload for AI, it becomes useful to view the host CPU as an orchestrator more so than as the compute engine. Energy-efficient ARM CPUs are well suited to this task, and the open licensing model of ARM inspires innovators to create products around it. An exemplar of this approach is NVIDIA's own ARM-based Grace CPU, which will be available in 2023. Grace is purpose-built for accelerated computing applications such as AI that process large amounts of data. 2 years ago, we announced that we were bringing CUDA to ARM, simplifying the development of AI and HPC applications on ARM. Today, along with our partner Taiwan-based Gigabyte, we are happy to announce a dev kit. This dev kit can be used by application developers to prepare their GPU-accelerated apps for ARM. So there it is, democratizing the hardware for AI with a wide range of accelerators turned into myriad form factors by a broad ecosystem of system builders. 103 different server and workstation form factors from 16 different system builders. More every day. Now let's turn to the software of AI. Every AI workflow can be thought of as a 4-step process, in a loop. The first step is to take a large amount of unstructured data and prepare it by extracting and organizing its features. The second step is to use the prepared data to train the models. In many cases, the models are then validated or simulated before being used in production or in the physical world. And finally, the actual use of the models, which in turn generates more data that is then fed back to the process. This is the recipe of AI. Over the years, NVIDIA has applied this recipe to create application frameworks for a variety of use cases, including conversational AI, drug discovery, self-driving cars, robotics, virtual collaboration, and recommender systems, the engine of the internet. These frameworks help companies jumpstart their adoption of AI. For example, NVIDIA Clara is our application framework for AI-powered healthcare. It includes SDKs and reference applications for drug discovery, smart hospitals, medical imaging, and genomic analysis. One customer that uses Clara is AstraZeneca. With Clara, they created an AI model for generating new drug candidates that target a given disease while maximizing safety. This method has seen recent success, with in silico medicine using AI to find a new drug in less than 2 years. Companies across the world are using these AI workflows from NVIDIA to improve their businesses and to help their customers. A great example from Taiwan is TSMC. We all know TSMC as a giant of the technology ecosystem, producing millions of wafers every year for semiconductor and technology companies across the planet. Analysts have referred to TSMC as the Hope Diamond of the semiconductor industry. In fact, NVIDIA itself is a very large partner of TSMC. Proactively identifying defective materials and classifying them to minimize further defects is a critical aspect of the chip production process. Engineers at TSMC have developed an AI-powered system to automate inspection and defect classification. Their system is 10 times faster and more accurate compared to the previous human method. All of these AI workflows are built from the same essential software libraries and toolkits. Now, we have brought all these components together as NVIDIA AI Enterprise, a coherent, optimized, certified, and supported software platform for AI. NVIDIA AI Enterprise is fully integrated with VMware vSphere, the de facto standard of enterprise computing. It is licensed, priced, and supported in the same way as vSphere for a consistent experience. And it all runs on NVIDIA certified servers, mainstream volume servers that are constantly racked into enterprise data centers. 71 different servers from 16 vendors, and more every day. But the components of NVIDIA AI are useful for more than AI. NVIDIA AI includes Rapids, a set of libraries that accelerate machine learning on GPUs. The same libraries can also accelerate the core engines of big data processing, such as Apache Spark. Cloudera is the de facto provider of Apache Spark to enterprise data centers around the world, with over 5 exabytes of data under management. As the technology landscape has changed, Cloudera has developed Cloudera Data Platform, a hybrid data cloud platform that brings customers forward to new technology without having to reinvent their big data pipelines. As we speak, the 2,000 customers of Cloudera are migrating to Cloudera Data Platform. We are pleased to say that NVIDIA and Cloudera have partnered to add transparent GPU acceleration using NVIDIA Rapids. A fully integrated solution from Cloudera will be available starting this summer with the release of CDP version 7.1.7. Customers do not need to understand Rapids or change their workflows in any way in order to obtain the benefits of this GPU acceleration. An example of an early customer is the United States Internal Revenue Service. With 0 changes to their fraud detection workflow, they were able to obtain 3 times the performance simply by adding GPUs to their mainstream big data servers. This performance improvement translated to half the cost of ownership for the same workload. But even as the world is transformed by AI, another shift is underway, amplified by the global pandemic. It is becoming more and more important for virtual teams of people in different locations to collaborate in real time. This is especially true for 3D workflows, from visualizing architecture to creating photorealistic content for games and movies, to simulating physically accurate worlds. This is a domain NVIDIA is very familiar with. And the same GPUs and systems we talked about in the democratization of AI are in fact the ideal foundation on which to build a platform for real-time collaboration and simulation of 3D designs. This is NVIDIA Omniverse. Omniverse makes it easy for teams to collaboratively design and simulate in 3D. We built Omniverse with open standards based on Pixar's USD, a powerful file framework and scene description language. With open standards, Omniverse enables teams to connect and work across multiple design applications or asset libraries in real time and at the highest fidelity. Just as we did with AI, we have put the functionality of Omniverse into an enterprise-grade software platform, NVIDIA Omniverse Enterprise. Omniverse Enterprise can run on any NVIDIA RTX-powered infrastructure, from professional laptops to workstations to GPU-accelerated virtualized or bare metal servers. We are excited to partner with leading global system providers who will offer NVIDIA Omniverse Enterprise later this year, starting at just $14,000 per year per company. The Omniverse subscription comes with connectors, which are plugins for the world's most important third-party design applications, allowing multiple designers and creators to use their preferred tools while simultaneously editing a scene together. Companies around the world and across industries are already using Omniverse to collaborate in amazing ways. Let's see how Omniverse is ushering in a new era of virtual worlds.
Where are you from, Misty?
I'm from a place called Omniverse.
So, there you have it. It is time to put accelerated computing to use for every company. This is a giant opportunity and responsibility for all of us. What we've talked about today are three essential ingredients built by NVIDIA: the hardware foundation from which to build any system, the software platform for artificial intelligence, the software platform for collaborative design. Together, we can use these three ingredients to transform every company. And yet, this is the same hardware and software technology that is at the heart of GeForce, the gaming GPU, which is where it all began. Thank you. Thank you for joining us today. Thank you for being with us every step of the way. And thank you for continuing forward with us on this amazing journey.